Hello, fourth grade. Today we're starting lesson 5.6, use partial quotients to divide greater dividends. So in our previous lesson, we had our three-digit numbers. Now we're going to continue talking about dividends and how we can use our divisors to help us find those quotients. And one of the ways that we're going to do that is by achieving this goal about thinking about multiplication, estimation, and place value. Let's go ahead and begin our solve and share on page 189. And in this lesson, our math tip for the day is you can use what you know about place value and the relationship between multiplication and division to help solve the problem.
The new reading room in the library is 9 feet long. It is divided into a reading area and a help desk area. It has a total area of 153 square feet. What is the total width of the new reading room? Use this model to help solve this problem. Solve this problem using any strategy you choose.
So here we can see the area for the reading area. We know it has 9 feet by 10 feet. And here we have an unknown amount of feet in the help desk area, but the total area is 153 feet. So using what we know, we can figure out how much this area is. And since 9 feet is over here, we can go ahead and figure out that the other side will also have 9 feet, and then figure out what our area is for this part by subtracting the area for this part. So if you try multiplying 9 times 10, you should get 90 here. So we can subtract 153. 90, 153, take away 90. Okay, so we have 153 here. And we know that 9 times 10 makes 90, so we're going to remove 90 because that's the area of this spot, 90 feet. And so now we can put the 3 right there. Since we have 15 tens, take away 9 tenths. 15 take away 9, that's going to give us 63 feet. And so now we know that this area will have 63 feet. And we know that this side will have 9 feet. And so let's think about what times 9 can give us 63. And so that will be F. And when we think about the multiples of 9, 9 times 5 equals 45. 9 times 6 equals 54. 9 times 7 equals 63. So that means 7 feet. So here we know that we have 63 for our part right here. And so 9 times 7, that'll give us 63. And so now, if you wanted to think of this as a division equation, you could have done it this way. So 9 on the outside as our divisor, and then on the inside of the dividend, 153. And so think about how we can't divide 9 into 1. We can't make 9 groups out of one group. So instead, we can look at 15 or 150. And so when we think about 150, 9 times what equals 150? Well, I know that 9 times 10 will give me 90. And so I can go ahead and remove 90 as my partial quotient. Bring the 3 down, same like we did over there. Get 63 left over, and now 7 groups. And so I have 63 minus 63 is 0. And so now our partial quotients were 7 and 10, or 17 with no remainder. So that means that we have 17 feet wide for this part right here. 17. Let's go ahead and continue to our lesson. And right now we're on page 190.
How can you use partial quotients to divide greater dividends? A total of 277 people signed up to audition for a talent show. 5 people at a time were brought in for a group interview. How many group interviews were needed to audition all 277 people? Find 277 divided by 5. You can estimate and use partial quotients to divide. How many 5s are in 277? Estimate. 5 times 40 is equal to 200. 5 times 50 is equal to 250. 5 times 60 is equal to 300. 60 is too many, so use 50. After 50 groups are interviewed, how many people have been interviewed in all?
Select your answer.
"250 people have been interviewed. There are 27 people who still have not been interviewed. How many 5s are in 27? Estimate. 5 times 5 is equal to 25. 5 times 6 is equal to 30. 6 is too many, so use 5. There are 2 people left over. How was 277 broken apart to divide by 5?
Five times 50 equals 250. 5 times 5 equals 25.
277 was broken apart as 250 plus 25 plus 2.
Breaking apart big numbers makes them easier to divide.
Divide until the remainder is less than the divisor. 2 is less than 5, so there are no more 5s in 277. 277 divided by 5 is equal to 55, remainder 2. What do the quotient and remainder mean? How many group interviews were needed? There were 55 group interviews with 5 people in each group. 2 people remain. A total of 56 group interviews were needed to audition all 277 people. A total of 277 people signed up to audition for a talent show. 5 people at a time were brought in for a group interview. The number of group interviews needed was found by dividing 277 by 5 equals 55, remainder 2. How can you use multiplication and addition to check the answer?
So since we know that division is the inverse operation of multiplication, let's go ahead and try multiplying by this answer to see if we get that number after we add that 2. So now let's try multiplying 55 times 5. And so if you do 5 times 5, you'll get 25. With 2 above, 5 times 50 becomes 250 plus 20 more becomes 270. So you have 275. And don't forget, we have to add the remainder, which is 2. So plus 2, and that equals 277. So the remainder is always added on. Let's go ahead and begin the guided independent practice. And this is another example of using the area models as a way for you to solve division problems. So again, using partial quotients, and of course, estimating to get to the closest possible quotient, so that way you can find when the quotient gives, when the quotient is evenly fitted, then there shouldn't be any remainders. If there is a remainder, make sure that it's less than our divisor. Let's go ahead and begin our notes. So we're on 5.6, use partial quotients to divide greater dividends. Estimating can be a helpful strategy to find partial quotients when dividing. For example, 277 divided by 5, or 5 on the outside, and then 277 on the inside. I know 5 times 5 equals 25, and I can estimate a product near it. Like 5 times 50, which equals 250, which is close to 275. So when I write it down, it'll look like this. 250 on the bottom, 50 on top. And when I subtract it, I'll get 27 left over. 50 is my first partial quotient with a difference of 27. I know there are 5 groups of 5 and 27 because 5 times 5 makes 25. So now I can go ahead and write that 25 on the bottom. When I subtract it, I get 2 left over. So now here, I'm going to go ahead and put my whole quotient here, which is 50 plus 5, so 55 with a remainder of 2. Since 2 is less than the divisor, the remainder is 2. So remember, your answer, your quotient, your remainder always has to be less than that divisor. So there are 55 groups of 5 and 277 with a remainder of 2. Dividing is finding how many equal groups of a number in a dividend, and rounding or estimating is one of the ways to get to the closest partial quotient and the smallest remainder. For example, here, 6 divided by, or 1,968 divided by 6. 1,968 is near 1,800, and 6 times 3 equals 18, or 6 times 300 equals 1,800, which I can subtract after I put the partial quotient. So here, my first partial quotient was 300, and I went ahead and put the 1,800 underneath, and I got 168 as the difference. 168 is near 120 because 6 times 2 equals 12, or 6 times 20 equals 120, subtracted after I multiply the partial quotient. So here, again, I put my 20, and then I put my 120, and I get 48. 48 is a multiple of 6 because 6 times 8 equals 48. So I can use it as my last partial quotient, and that's why I put an 8 right there. And you'll see 48 minus 48 equals 0. So in this case, we don't have a remainder. So now, the fourth step, there's 200 plus 20 plus 8 equals 228 groups of 6 in 1,968. So here for number 1, it says Hillary has 254 tokens for use for games at Pizza Mania. She would like to use an equal number of tokens for each of the 3 visits she has planned. Will Hillary be able to use the same amount of tokens for each visit? So now let's find out by dividing 254 divided by 3. And so let's see if we can get an even amount, the same number, and equal groups. So if we were dividing 254 divided by 3, then you can do it this way, or if you wanted to use it as your partial, with your partial quotients, that's fine as well. In this case, I'm going to give myself a little bit of space, so that way I can go ahead and have more room. See, I can move all of that down here. That way I have more space. Okay, so now that we know what our equation is going to look like, let's go ahead and use partial quotients. So here, 3 can't be put into 2, but 3 can go into 200. So when we think about 3 times what equals 200, or 3 times what will get me close to 200, I can think about 20. Or if I want, I can go ahead and combine this 25, think of it as 25 tenths, and that'll give us 250. And so now, when I think about the number 25, 3 times what is close to 25? Well, I know 3 times 80, or 3 times 8, will give me 24. So 3 times 80 will give me 240. And I can go ahead and subtract that. So I'll have 4 down here. 5 minus 4 is 14. And so now 3 can go into 14 how many times? Well, I know that 3 times 2 equals 6, 3 times 3 equals 9, 3 times 4 equals 12, and 3 times 5 equals 15, so I can't go larger than it, so I'm going to stick with my 4. I'll get 12, and I'll have 2 as a remainder. So the question was, will she be able to use an equal amount or the same amount of tokens for each visit? Since there's a remainder down here, that means that her quotient will be 84 with a remainder of 2. So that means that she can use 84 2 of the times, and then, or technically 3 of the times, but she will have 2 left over, so she won't be able to. So Hillary can use 84 tokens for 3 visits and have 2 left over. Or she can have 85 tokens for 2 visits and then 84 for one of them. So no, she will have 84 tokens for 3 visits and 2 remaining. Or if you wanted to rewrite that as 85 tokens, 2 visits, and 84 for 1, that's also correct. For numbers 2 through 3, use partial quotients to divide. How many 4s are in 6,787? And so now, if I write this as my long division, I'm going to go ahead and show it this way. With 4, I have 6, 7, 8, 7. I know 4 can go into 6 one time. So if I want to use partial quotients, that's fine. In this case, I'm going to go ahead and use my long division. So now I'm going to go ahead and subtract 4,000. And I'll get 2,000. And now I can go ahead and look at my next, oh, I forgot. Let's go ahead and bring down the other ones. 2,700. I'll use 27 for right now. And so 4 can go into 27. How many times? Well, I know 4 times 6 is 24. 4 times 7, that's going to be 28. So I'm going to use 6 for right now. 600. And so now I'll go ahead and put my 24. And when I subtract it, I get 3. And I have an 8 here, so 38. I'm going to write it over there so that way I can show my equation. So now 38, or technically 387. So now 4 can go into 38 how many times? Well, I know that 4 times 8 equals 32. 4 times 9 equals 36. And that's pretty close. So I'm going to go ahead and put my 9 there. And so I get 36. And then I subtract it. And I'll get 2 left over. And I have a 7. So now 4 times what equals 27 or something close to 27? Well, 4 times 5 equals 20. 4 times 6 is 24. 4 times 7 is 28. So again, I'm going to stick with my 6. And then I get my 24. And then I'm going to combine or remove it. And I get 3 left over. So I have 1,696 as my whole quotient. So 6,787 divided by 4, oopsie, equals 1,696 with the remainder of 3. And then how many 5s are there in 6,209? So again, I'm going to put my 5 over here because I want to have space. 6,209. I know 5 can go into 6. 6,000 at least 1,000 times. Or if I want to look at 62, I can go ahead and use my partial quotients for this one. So now I'm going to go ahead and do 5 times 12. That'll give me 60. 5 times 1,200. That'll give me 60,000. Sorry, 6,000. And now when I subtract it, I'll have 20 on the bottom right here. 5 can go into 20, 40 times. And so I'm going to go ahead, put my 20 down there, because it's technically 209. So think of it like that. And so now we're going to subtract it again. And I only have the 9 left over. 5 can go into 9 one time. So I remove the 5. And I'll get 4. So now my partial quotients, 1,241, with a remainder of 4. So that's how many times 5 can go into it. 1,241 groups of 5 with a remainder of 4. All right, that is the end of this lesson. And so now we're going to go ahead and get started on our independent practice and our problem solving. Please make sure you write your answers neatly so that way your work can be graded accurately. And please make sure to complete the front and the back. All right, I'll see you in our next lesson.